Hello students, so here we are with the question first of the exercise 4.3 of the chapter Quadratic Equations. So the question first is find the roots of the following quadratic equations if they exist by the method of completing the square, and the two quadratic equations are provided in this case. As we know, we need to solve this by using the method of completing the square. What it means is that we need to apply the identity in equation, that is a plus b whole square or a minus b whole square, as the case might be. But it may also the case that we cannot directly apply the identity from the quadratic equation being provided in question, that is in the form which the question has given the quadratic equation. So we need to convert then quadratic equation in such a form, that is we need to do the mathematical manipulations in such a way that it results into the use of the identity a plus b whole square or a minus b whole square. How? Let's see by solving the first quadratic equation, which is 2x square minus 7x plus 3. As directly we cannot apply here the identity. But if we observe the first term, then this term is not a perfect square, as that x square is a perfect square but 2 is not a perfect square. So in order to convert this term into a perfect square, what I'll be doing, I'll be multiplying both the sides with the number 2. So that this will result into 4x square, which is a perfect square. So on multiplying, I'll be getting 4x square minus 14x plus 6 is equals to 0. Now 2x can also be written as 2x whole square 4x square, है ना? Right? And then minus 14x. In order to write 14x, I'll be using 2 into 2x, as here a is 2x. If we remember the identity, a plus b whole square, what was that? A square plus b square plus 2ab. And what was a minus b whole square? It was a square plus b square minus 2ab. So in this case, I am writing a to be 2x. So I can write 14x as 2 into 2x into 7. But here I am getting 2 in addition, as it was not in the term. So in order to cancel out its effect, I will be dividing also with 2. So this will be the terms. And if I observe the middle term, it just looks like 2ab, where a is 2x and b is 7 by 2. But here I don't have a term 7 by 2 whole square, that is b square. So in order to get the term b square, I'll be adding and subtracting b square on the left hand side. So here it will be 2 into 2x into 7 by 2 plus 7 by 2 whole square minus 7 by 2 whole square plus 6 is equals to 0, which can also be written as 2x minus 7 by 2 whole square, as we can easily apply the identity over the first three terms, as they are similar to that of the a square minus 2ab plus b square, where a is 2x and b is 7 by 2. And on solving this, these terms 7 by 2 whole square and plus 6, I'll be getting the terms plus 24 minus 49 by 4 is equals to 0, which can also be written as 2x minus 7 by 2 is equals to 5 by 2, right? But as we know, on taking the square root on both the sides, before doing any square root, just see the term 5 by 2. 5 by 2 term can also be written as root 5 by 2 whole square, as 2 and root 2 will be cancelling out each other, resulting into 5 by 2 only. So if I take the square root on both the sides, I'll be getting the terms 2x minus 7 by 2 is equals to plus minus root 5 by 2. Why? Because any number on squaring results into the positive number. And as we are doing the square root, then means the initial term can be positive or negative, which would have resulted into the number 5 by 2, that is on squaring. So there are two possibilities. So the first possibility is 2x minus 7 by 2 is equals to 5 by 2. That is a positive term. So from here, 2x is equals to 5 by 2 plus 7 by 2, which is equals to 12 by 2. From here, x will be equal to 12 by 2, right? And into 2, that is 2 of this. So it is equals to 12 by 4, which is equals to 3. That is from here, x is equals to 3. But if I take the value minus root 5 by 2. So coming to the second case, that is 2x minus 7 by 2 is equals to minus 5 by 2. Right? So now it will be, here it's going to be square, right? So now I can write 2x is equals to minus 5 by 2 plus 7 by 2. That is 2x is equals to 2 by 2, or I can say 1, and x comes out to be equal to 1 by 2. So the two roots of the x are 3 and 1 by 2. That is, I can write the value for variable x be equal to 3 and 1 by 2, which we have obtained by using the squaring method, that is by applying the identity a minus b whole square, right? Now on coming to this b part, here the equation being provided is 2x square plus x minus 4 is equals to 0. Again, if we observe the first term, then this is not a perfect square. So again, I'll be multiplying both the sides with the number 2. So on multiplying with the number 2, I'll be getting 4x square plus 2x minus 8 is equals to 0. And also, I can write 2x square as 4x square. And if I write 2x as 2 into 2x into, on cancelling the effect, 1 by 2. That is, in order to form this middle term as 2ab, where a I know is 2x and b happens out to be 1 by 2, because I need to cancel out the effect of multiplication 2 which I have taken. So it will be 2 into 2x minus into 1 by 2. But here if I observe the term, it looks like 2ab, where b is 1 by 2. So in order to get the term b square, so that I can easily apply the identity a plus b whole square, I'll be adding 1 by 2 whole square, as well as I'll be subtracting 1 by 2 whole square. Minus 8 is equals to 0. So now apply the identity over the first three terms. They look similar to like a square plus b square plus 2ab, where a is 2x and b is 1 by 2. So this is whole square. Minus 8 minus 1 by 4 is equals to 0. Right? Or 2x plus 1 by 2 whole square is equals to root 33 by 2. Right? And I can take the square and the under root on both the sides. Right? So on taking the square root, I'll be getting either the positive or the negative this term. So the two cases arises such that 2x plus 1 by 2 is equals to root 33 by 2, and the second case is 2x plus 1 by 2 is equals to minus root 33 by 2. That is taking the positive and the negative term separately. So from here, x will be equal to minus root, here x will be equal to, yes, root 33 minus 1 by 2 into 2, which is equals to root 33 minus 1 by 4. And from here, 2x is equals to minus root 33 minus 1 by 2, or I can write x as minus root 33 minus 1 by 4. So the two roots which I have obtained by using the method of completing the square are x is equals to root 33 minus 1 by 4 and the another one is root 33 minus 1 by 4. So these are the two roots of this equation, that is quadratic equation 2x square plus x minus 4. So now coming to the third quadratic equation. So the equation is 4x square plus 4 root 3x plus 3 is equals to 0. So this is the quadratic equation being provided in the question. And as we know, 4x square can also be written as 2x square. And we can also write the term 4 into root 3x as 2 into 2x into root 3 plus 3 can also be written as root 3 whole square, which is equals to 0. Means we have just changed how to write the equation, but the equation is the same as being given in the question. Now if we observe this equation, then don't it looks like a square plus b square plus 2ab, where a is 2x and b is root 3. So applying the identity over here, that is a plus b whole square, where a is 2x and b is root 3. So this becomes 2x plus root 3 whole square equals to 0. So now taking the square root on both the sides, it becomes 2x plus root 3 is equals to 0. Or we can also write it as 2x is equals to minus root 3, or x becomes minus root 3 by 2. So we have obtained the value for the variable x, which comes out to be equal to minus root 3 by 2. But as we know, the quadratic equation have two roots, then what will be the value of the another roots? The next root will also be minus root 3 by 2. Means whenever such condition occurs, when the variable x acquires only one value, then that root, or we can say that value, is said to be double root. Okay. Now coming to the D part, here the equation being provided is 2x square plus x plus 4 is equals to 0. Now if we observe the first term is not a perfect square, as x is perfect square but the 2 is not a perfect square. So in order to make it a perfect square, I'll be multiplying both the sides with the number 2. So this becomes 4x square plus 2x plus 8 is equals to 0. Okay, we can also write 4x square as 2x whole square plus, in order to make this term to be 2ab, so that we can easily apply the identity of the square, complete square, I'll be multiplying as well as I'll be dividing with the number 2, so that it don't have an overall effect on the term. That is, this term again comes out to be equal to 2x as it was before. So this will be 2 into 1 by 2 into 2x. And if we observe this term clearly, it can form 2ab only and only if b is equals to 1 by 2 whole square. That is, b square comes out to be equal to 1 by 2 whole square. But we have the constant term 8, not 1 by 2 whole square. So in order to make it 1 by 2 whole square, we will be adding 1 by 2 whole square as well as subtracting 1 by 2 whole square, so that it don't have an overall effect on the equation. So now we can easily apply the identity over this term and this term, that is a plus b whole square, that is 2x plus 1 by 2 whole square plus 8 this term and minus 1 by 4, which is equals to 0. Right? Or we can also write it as 2x plus 1 by 2 whole square is equals to minus 31 by 4. Now if we see this term, then on taking the square root, here inside the square root there will be the negative term, or we can say this is the case same as y square is equals to minus a. That is, if I take the square root of y, then this term will be root minus a. And as we know, if there is a negative term inside the square root, then this will lead to a non-real number. So, the number which we can obtain after square rooting both the sides will definitely be a non-real number instead of a real number. But we only deals with a real number while finding the roots of the equation. So, we can conclude from here that real root of given equation does not exist. Why? Because this is a non-real number on square rooting. That is, if I took a square root of this term, then this happens out to be a non-real term, which is not possible. So this was about question first of exercise 4.3. I hope this question is clear to all of you.